Okay, to solve this problem, to determine the payback period, simple payback period, let's just provide this table. If I want to consider a payback period of 1 year, so for the first year, at first I have spent $18 million. And if I want to have it for 1 year, I have a positive cash flow of $3 million. And also I have the salvage value because they said no matter at which year I sell it, salvage value will be 3. Let's say if I can sell it at the end of year 1, I can make $3 million. So my cash flow will be, the total cash flow will be negative 12. If I want to keep it for 2 years, what will happen? Again, I spent $18 million at the very beginning. For 2 years, each year will give me $3 million plus I have a $3 million, which is our salvage value, and it will be negative 9. If I want to keep it for 3 years, it will be negative 18 plus 3 plus 3 plus 3. Plus, if I want to again sell it over here, it will be salvage. I will have a salvage value of 3, so it will be negative 6. If I want to keep it for 4 years, if you do the calculation, you will see it will be negative $3 million. If I want to keep it for 5 years, you will see that my total net cash flow will be equal to 0. If I want to keep it, for example, for 6 years, cash flow will be equal, the net cash flow will be equal to 3. So therefore, I can say that because of this reason that your, I would say net cash flow is equal to 0, I can conclude that my payback period, simple payback period, is equal to 5 years. It means that if there is no interest rate, it will take 5 years for me to recover the initial investments that we have. That was simple payback period because we didn't have any interest rate. But it's very logical to ask this question: what if I have some sort of interest rate that is not equal to 0? So in these cases, as I talked about that earlier, we call it discounted payback period. So talking about discounted payback period, it means that I'm talking about the scenarios that your I is not equal to 0, or so say it's greater than 0%. We said to solve this type of problems, to determine the value of payback period, the easiest way to do is to calculate the present worth and set it equal to 0. And of course, n is missing. So let's say, for example, I have a cash flow diagram that I have spent $10,050 here, and for year 1, year 2, and it continues. So let's say I have a cash flow diagram that is, what I say, let's just have something like 1,000 here. It's 1,000 your cash flow, and for example, you can make $100 afterwards per year, for example. You need to determine present worth as a function of n, set it equal to 0. For example, present worth of this as a function of n will be equal to this $1,000 will be already at times 0. You don't need to do anything for that. Plus 100. I want to find P for that given a interest rate. Let's say assume it is equal to 10%, but n is missing. Set it equal to 0. You can determine the value of n. That will be the concept of payback, discounted payback period when you have when you have your I greater than 0. With this introduction, we are ready to solve some examples. Let's just look at one problem. Just look at problem 1321. So I want you to read this problem first, and after you read this problem, pause the video for a couple of minutes until you're done reading this problem. Pause it until you're done solving this problem, and again continue watching this example. So the annual cost is given per year. The material cost per square yard is also given. And you have another option that's regular street resurfacing requires equipment that has this time first cost of this much with a 15-year life, no salvage value. Variable cost for regular resurfacing is $13 per square yard. You have to be careful about the units. It's one of the key things that you need to consider. And at interest rate of 8% per year, how many square yards per year must be resurfaced for the two methods to break even? So technically, the value that you are looking for is the value of x, which is the square yards per year. That's the value that you are looking for. So I have two options. I want to know at which value of x these two options will be equal. So first one has the initial cost of has a cost of 109 per year. 109, again be careful about the units. $109,000 per year, plus they said the material cost is 275 per square yard. So if it means that if I produce, for example, if I have x square yards, I have to pay this much. And again, it will be dollar per square yard. And it should be equal to, it has the first cost of 225. Something that you have to pay attention is that this is the first cost of 225, but the 109 that we have is annual cost of the equipment. So it means that over here it's really like A, but the value of 225K is the first cost. So I have to convert that to A because you have to be careful about the units, and you can set them equal when they have equal units of time. So I have to convert that 2025 to A for that given P interest rate of 8%. And they said it has a 15-year life. And they said it would cost $13 per square yard for as a variable cost. It would be $13 times X, which is a square yard. So as you can see, I can find the value of A given P 8% and 15 from the table, probably 0.11683, set them equal, and therefore you will, if you do the math, you will see the value of x will be 807 square yards, I would say square yards per year. That will be the answer to this question. So the next example that we are going to solve will be problem 31 from from your book. Again, after you read this problem, please pause the video. Make sure that you will give yourself some time to solve this problem. Once you're done solving the problem, continue watching the video for solution. So in this problem, the company has constructed an addition to the building with a cost of 70K. Extra annual expenses are expected to be 1,850, but extra income will also happen. How long will it take for the company to recover its investment at an interest rate of 10% per year? So actually, it's also asking about a spreadsheet that I'm gonna ignore at this point. Okay, so they have the cost of $70,000 year, and starting from year 1, 2, 3, probably up to some year that we call it N, and I don't know when that is. I will have the income of 14K and I have annual expense of 1,850. Okay, so we said to determine the value of N, we know the payback period because it's the definition of payback period. How long does it take to recover your initial investment? So you can say, you can set these things really equal, which is 70,000, and it's equal to, as you can see per year, I have 14,000 positive, I have 1850 negative. So it will be your A value. I want to find the value of P for that given A, interest rate of 10%, but this time I don't have the value of N. So if I do the math, I will see P given A factor is equal to 5.7613. Okay. Actually, if I go to a table that we have for 10%, if you look at the table 10%, look at the column of P given A. You want to find the closest number to this. P given A, 10% and 9 is equal to 5.7590. So it seems that the value of N that we are looking for is slightly greater than N. If you really want to find out the exact amount, you have to do some interpolation. P given A, 10% and 9 is there. P given A, 10% and 10 is equal to 6.1446. But the value that you are looking for, which has N, P given A, 10% and N is equal to 5.7613. If you do the interpolation, you will be able to determine the value of N, which is 9.05 years. These digits of accuracy are important because if, for example, you translate them into hours in this scenario, that 0.05 really makes a big difference. Okay, so do not just eliminate the digits of accuracy that you have. Okay, the next example that we are gonna solve is problem 1337. Again, I want you to read this example first. After that, pause the video and After you pause it, give yourself some time to solve it, and then again, continue watching the video for the solution. So two machines can be used to produce a part, and the cost and the cash flows are given. Salvage values are constant regardless of when these machines are replaced. You want to determine the value, which alternatives should be selected if alternatives must have 5 year, a payback of 5 years or less. So you want to do to solve this problem when I is equal to 0 and once when I is equal to 10%. Okay, when I is equal to 0%, I'm talking about part A. When I is equal to 0%, we want to determine the payback period for each scenario. So let's just call them alternative S semi-automatic and A alternative automatic. So when I is equal to 0, we said, no matter what we said, we always say present worth of whatever you have, let's say as a function of n, set it equal to 0. And it will be negative 40. I can drop 3 zeros plus 10 times n. Let's just use small n. And set it equal to 0. So n will be 4 years. But for automated scenario, I have to calculate the present worth, set it equal to 0, and present worth of A, it will be negative 90 plus 15 times n. I set it equal to 0. Therefore, n is equal to 6 years. So A has a payback period that is greater than 5 years. But this question, they said if alternatives must have a payback period of 5 years or less. So 6 is greater than 5. So therefore, I would say you will select alternative A. Also alternative S, semi-automatic. S will be selected because it has its payback period within the requested window of 5 years. Okay. The next option that we have is the scenario that you see over here. Your I is equal to 10%. Again, we say present worth of, for example, semi-automatic as a function of n should be equal to 0. So therefore, at time 0, I have negative 40 plus I have that 10. I want to find P for that given A, 10% and N, set it equal to 0. P given A, 10% and N will be equal to 4. If you look at the tables that we have for 10% and see where you have the value of P given a factor to be equal to 4, you will see that your N is a number between 5 and 6 from the tables. You see N is a number between 5 and 6. For second alternative, the automated scenario, as a function of N, it will be again negative 90 plus 15. You want to find P for the given A, 10% and N. I set it equal to 0. Therefore, the value for P given A factor for 10% is equal to 6. If you look at the table for 10%, look at the column for P given A, see where you can get close to the number 6, you will see that your N is between 9 and 10. So the question over here was to determine which alternative will you select. If alternative must have a payback period of 5 years or less. This one is more than 5 years. This one is more than 5 years. Therefore, I conclude that there is no viable alternative, or no alternative is selected. No alternative is selected. With this example, I can wrap up chapter 13. So again, chapter 13, we talked about payback period as well as break-even point. We said break-even point is the point that your total profit is equal to 0, and payback period was the duration of the time that it takes to recover your initial investment. Thank you everyone for watching this video.